David Smith here with another Flip Classroom math lesson. 3 tips before we start. First, you can adjust the playback speed if that helps you get through the video. Second, you can pause the video at any point to take notes or work the examples. Third, you can turn on the captions and read my words go by on the screen. Today, we're going to talk about rational functions in a more complex form. So that form indeed is f of x equals ax plus b over cx plus d. So a couple things to notice here. First off, we're introducing putting our variable in the top and the bottom, in the numerator and the denominator of our rational function. And then also we've got multipliers on the x on both top and bottom, and then we've got a constant being added or subtracted from the top and from the bottom. So let's take a look at a bunch of functions and see if we can derive some simple formulas for finding asymptotes and a simple technique for graphing. So let's get started. So check this one out. Pretty basic. We just have x over x plus 2. What I want you to do is pause the video, pull out your graphing tool, and let's make a graph of this function. And I'd like you to show the asymptotes on your graph, on your sketch, with dashed lines and write their equations. So here's the graph I get. I've got my asymptotes at x equals minus 2 and y equals 1. And then from my calculator, it shows me that my curves are here. They're mostly in quadrant 2 and quadrant 4, although they do overlap. And my graph also shows that this function goes right through the origin. So the x-intercept and the y-intercept are indeed at 0, 0. So let's do another one. All right, so my calculator showed me that my horizontal asymptote is at y equals 2, my vertical asymptote is at x equals negative 2, and then I went ahead and I figured out what my intercepts are because I need to know where the curve is. If I wasn't using the calculator, my intercepts don't really tell me whether the curve is in mostly quadrant 2 and 4 or 1 and 3. So what I did is I checked my asymptotes. So remember how the y asymptote happens when x is 0, so you plug 0 in and that becomes 1/2. So here's my y-intercept, 0, 1/2. And then the x-intercept happens when y is 0, so I did that over here. This is 0 equals this equation. Now check this out. All I really need to do is find when the top is 0, because when the top is 0, the equation is 0. You notice that we'll never have 0 in the bottom because we have undefined, and that gives us this asymptote. So all I have to do is take my top, set it equal to 0, and find out what my x-intercept is. So that was this little equation there. X is negative 1. So here's my x-intercept, 0, negative 1. So that's 2 points that confirm that my curve is mostly here down near quadrant 4 and also up here in quadrant 2. All right, now pull out your calculator and graph this one and come back with a nice sketch graph with your asymptotes labeled. All right, check this one out. I got my graph. My horizontal asymptote is y equals 2. My vertical asymptote is x equals negative 2. And then I found my intercepts, and this one was pretty easy. The y-intercept happens when x is 0. I plug 0 in for x. The whole equation goes to 0. So that means that my intercepts are the same. They're at the origin. And then that point confirms that my curve, again, is in this zone and in that zone. All right, let's try another one. Here is we're adding a little more complexity, and notice how I switched the sign on the bottom. So pay attention to your graph and think about your intercepts, label your asymptotes. All right, here's from my graph. I have my horizontal asymptote at y equals 2, my vertical asymptote at x equals 2, and then I sketched my curves in here because I found my intercepts are right there. So what I'd like you to do is pause the video right now and just figure out what those coordinate points are for the intercept, because I did that so I could graph them correctly. So those points are 0, 1/2, and 1/2, 0. So here's our y-intercept and there's our x-intercept. Here's how I found those. To get the y-intercept, you set x equal to 0, so these two terms go away. So I have minus 1 over minus 2, which is just 1/2, which gives us the y-intercept. To find the x-intercept, I just set the top equal to 0, because that's what makes the fraction go to 0. So 2x minus 1 equals 0. That reduces down to x equals 1/2, which gives us that intercept, 1/2, 0. So that told me that I need to put my curves in these quadrants, which is different than our previous graphs. One last graph and then we'll move on. So here's your function. I'm increasing the complexity. We have 4x plus 1 over 2x minus 6. Go ahead, pause the video, same things. Label your asymptotes, your intercepts, and make your graph. All right, so here's my graph. I have a horizontal asymptote at y equals 2, a vertical asymptote at x equals 3, and my two intercepts I found are right there, which again gives my curve to be in this zone and that zone. If you haven't already figured out what those intercepts are, do that now. So here's what I get. I have this intercept at minus 1/4, 0, and then this intercept is at 0 minus 1/6. And here's my math for that. When I set x equal to 0, the fraction just goes to negative 1/6, so there's the y-intercept. And then when I set the top equal to 0, 4x plus 1 equals 0, solve for x, I get minus 1/4, 0. So that gives me the graph, that gives me these 2 points, and then that tells me that my graph goes through here and through there. Now, technically, to figure out where to draw your curves, you only need one intercept because that will place the curve in the correct quadrant, and then you'll be able to make your graph. All right, I'm going to give you a task that would require a bunch of critical thinking. So see if you can pull this off. What I'd like you to do is look at those last 5 graphs we did and see if you could come up with a way to determine the vertical and the horizontal asymptotes simply from the equation. Because you have your A, your B, your C, and your D, and it's true you can do that. There's a kind of a plug-in step where you just look at your equation, use the letters, and come up with your equations for your asymptotes. So you have enough information in those graphs with the asymptotes and the equations that you can compare your letters and see if you can come up with that. So pause the video, think real hard, write something down, and come back. Let's see how you did. It's pretty straightforward, and these are not in your formula booklet, so you need to know these if you're graphing rational functions in the non-calculator portion of the test, which you will be required to do. So check this out. The vertical asymptote is just minus d over c. So whatever this term is, change the sign and put it over c. And that will give you the vertical asymptote every time. Horizontal asymptote is similar, but instead of minus d over c, it's just a over c. So you just grab the a term and you put it over the c term, and that gives you the horizontal asymptote. Let's do an example and show you how this works. This problem is a non-calculator problem. So follow my prompts, but do it without your calculator. First step, look at that function, figure out your A, B, C's, and D's, and write me the 2 equations, one for the horizontal and the other for the vertical asymptotes. Here are my asymptote equations. For the vertical asymptote, I just plug in my minus d over c, so I have my minus 2, my minus 2 over 3, which gives us 2/3. So there's the equation for the vertical asymptote. The horizontal asymptote is just a over c. There's a 1 in front of my x there, so there's 1 over 3. So my horizontal asymptote is 1/3. Now, what I'd like you to do, pause the video and create a sketch graph. Again, no calculator. Do a sketch graph on your page of this rational function. All right, so here's my graph. What I did is I first sketched my asymptotes. And that's the way to do this. Those bind the curves into certain positions. So I sketched my asymptote at y equals 1/3. That's my horizontal asymptote. And my vertical asymptote is x equals 2/3. All right, what I'd like you to do now is take this rational function and do all the steps that we've been doing and create a sketch graph without your calculator of what this rational function looks like. Horizontal asymptote, y equals 1/2. Vertical asymptote, x equals minus 3/2. So I sketched those in there. I tested my intercepts, so I found that my y-intercept is down here at 0 minus 1/3. That's enough. Now I know my curve is in this area and this area. I went ahead and checked for that intercept because it was nice and easy. The x-intercept is 1, 0, and there is your graph. Now that you've watched the video, jot down a few extra notes or questions for our next class. You can also re-watch portions of the video that you didn't understand the first time. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.